However, there is an exception to this behavior. That is, your ligands H2O and oxalate, they show dual behavior. H2O and oxalate are weak field ligands with every other metal cation in the +3 oxidation state of the 3D series. But with cobalt 3 positive, H2O and oxalate are going to behave as strong field ligands. Now H2O is going to behave as a strong field ligand. It is going to cause pairing and it will give a low spin complex. With iron, H2O is not going to do that. With Fe3 positive, there is still going to be no pairing. Oxalate also does the same thing. Oxalate is a didentate ligand. In this also, CO is in a +3 oxidation state. So, pairing will happen and we will get a low spin complex. So, this behavior of H2 and oxalate, they show only and only with CO3 positive. So, this is the dual behavior or an exceptional behavior of water and oxalate. Now, let us do, again we are going to do for 3D series only, but in this case the cation is going to be present in a +4 oxidation state. So, if any metal atom is present in a +4 oxidation state and it belongs to the 3D series, then for that metal atom all ligands are going to behave as strong field ligands. It does not matter whether that ligand is present at the extreme left or the extreme right. It is still going to behave as a strong field ligand. That is, all ligands will produce pairing for any metal of the 3D series in +4 oxidation state. However, +4 oxidation state is not that commonly shown by the 3D series metal, but still if it is shown, then all ligands are going to behave as strong field ligands. Next we go on to the elements of the 4D series. So, all ligands will cause pairing for any metal of the 4D series in +2, +3 or +4 oxidation state. So, you can take any metal of the 4D series and you can take any cation. You can take +2 cation or the +3 cation and the +4 cation. For all of those cations, any ligand, whether it is going to be present at the extreme left or the extreme right, it is still going to act as a strong field ligand. It is still going to cause pairing. You are still going to get a low spin complex. Similarly, for your elements of the 5D series as well. In the 5D series, whether the metal cation is +2, +3 or +4, all the ligands are going to act as strong field ligands for the elements or metal atoms of the 5D series in any oxidation state. So, these are some kind of thumb rules to predict whether a ligand is going to behave as a strong field ligand or a weak field ligand with a particular metal. So, for that you should know what is the oxidation state of that metal atom. That is the main thing that we should know, what is the oxidation state of the metal atom, and based upon that we can predict whether it is going to show strong field ligand behavior or whether it is going to show weak field ligand behavior.